In today's lesson, we're going to work with pyramids and composite prisms, and we're going to start off by looking at the surface area of pyramids and composite prisms. In our first example, they ask us to calculate the surface area of the rectangular pyramid below. Looking at this rectangular pyramid, okay, I can see that it actually has a square base because the dimensions are 8 by 8, they're the same. And off of each side of this square base, there is a triangle that is 8 centimeters by 5 centimeters. Okay, so in order to find the surface area, I'm going to find the area of each face, and then I'm going to add them together at the end. So why don't we start with the square base? If I'm finding the area of a square, I'm going to use the formula area equals base times height. And I can see that, again, it's an 8 by 8 centimeter square. So I'm going to do 8 times 8, which is going to give me an area of 64 square centimeters for the base. Okay, and now I'm going to find the area of the triangles. Okay, a triangle uses the area formula 1/2 base times height. And I can see on my triangles that they're all 8 centimeters by 5 centimeters for their base and the height. 8 centimeters by 5 centimeters. So 1/2 times 8 times 5. Well, half of 8 is 4. 4 times 5 is 20 square centimeters. But there's 4 of these triangles that are all congruent. So I'm going to multiply 20 by 4, which means that the area of all 4 triangles is going to be 80 square centimeters. Now to get the total surface area, I'm just going to add together 64 plus 80, which is going to give us 144 square centimeters for the surface area. So again, we break the solid into two-dimensional shapes whose area formulas we know, and at the end, we just add them together to get the surface area. Our next example shows a trapezoidal prism, and once again, they'd like us to calculate the surface area. So I'm going to break this solid up into two-dimensional shapes whose area formulas I know, and once again, at the end, I'm going to add them all together to get the surface area. Now, this is called a trapezoidal prism because the base shapes are trapezoids. The trapezoid in the front and the back are parallel to each other, and more importantly, they're congruent to each other. So once I get the area of one of them, I'll just double it to get the area for both of them. So why don't we start there with the trapezoids? The area formula for a trapezoid, area equals 1/2 the sum of the bases, in parentheses base 1 plus base 2, multiplied by the height. Looking at my trapezoids, okay, if I look at the one here on the front, I can see that the bases are 4 yards and 10 yards. So in parentheses, I'll do 4 plus 10. And then the height is perpendicular to both bases, and that also is 4 yards. So area is going to equal half of 4 plus 10 is 14 times 4. And if I do half of 14, I get 7. 7 times 4 is 28 square yards. And now, since the front and the back are both congruent trapezoids, I'm going to double that. 2 times 28 equals 56 square yards. So that gives me the area of the bases, the trapezoid bases. Now I have 4 different rectangles whose areas I need to find. I need to find the top rectangle, this bottom rectangle, and then the right and the left sides. Why don't we start with the top rectangle? Area equals base times height for a rectangle. And looking here at the top, I can see that it's 4 yards by this measurement, which is the same as this measurement down here, 15 yards. So it's 4 yards by 15 yards. 4 times 15 is going to give us an area of 60 yards. Looking at the bottom rectangle now, once again, we use the formula area equals base times height. And I can see here on the bottom rectangle that this is 10 by 15 yards. So 10 times 15, that's going to give us an area of 150 square yards. Now I need to get the area of the right and the left. Okay, well, the right I can see is 5 by 15, and the left is also 5 by 15. So the right and left are actually congruent to each other. Right and left. Okay, they're rectangles, base times height. And again, they have dimensions of 5 yards by 15 yards. 5 times 15 is going to give us 75 square yards. But since they are congruent, I'm going to double that and do 2 times 75 to get a total area for those two faces of 150 square yards. Okay, now I'm ready to get the total surface area. And again, I'm just going to add everything together. So the trapezoids were 56 square yards, the top was 60, the bottom was 150, and the right and left combined were 150. So I add those all together, and that's going to give me a total surface area of, well, 150 and 150 is 300, plus 60 is 360, plus 56, that's going to be 416 square yards for the total surface area. In our next example, we're told that the base rectangle of a right rectangular prism is 4 feet by 6 feet. They also tell us that the surface area is 288 square feet. They would like us to calculate the height of that prism. And it says, hint, use the formula from last class. Okay, so for the surface area of a rectangular prism, recall that we can use the formula surface area equals 2 times length times width, plus 2 times length times height, plus 2 times width times height. Right, and I can also sketch a rectangular prism. That would look something like this. And they tell me that the base rectangle, so the one down here on the bottom, measures 4 feet by 6 feet. So I can call that 6 feet, I can call that 4 feet. And in the end, they want to know what the height is. H is the height that they are looking for. Well, if I think about my surface area formula over here, actually the surface area has been given to me. They told me right here that the surface area is 288 square feet. So I'm going to plug that in for surface area, 288. And then the base rectangle down here, well, that uses the dimensions of length and width. So I can call 6 the length and 4 the width, and just plug these values into the equation. So 2 times length times width, I'm going to do 2 times 6 times 4. 6 is the length and 4 is the width. Plus 2 times length times height. Length is 6. Height h is what we're looking for. Plus 2 times width times height. Width is 4. And again, height h is what we're looking for. If we clean this up a little bit, 288 equals 2 times 6 is 12. 12 times 4 is 48. Plus 2 times 6 is 12. 12 times h is 12h. Plus 2 times 4 is 8. 8 times 8 is 8h. So I have an equation here that I can use to figure out the value of h. First thing I'm going to do is combine my similar terms, 12h and 8h. 288 equals 48 plus 20h. And now I'm going to isolate the variable term by subtracting 48 from each side. 288 minus 248 is 240, and that equals 20h. To get the value of h, now I'm just going to divide each side by 20. All right, 20h divided by 20 is h. 240 divided by 20 equals 12. This means that the height is 12 and the units are feet. The height of the prism is going to be 12 feet. In our next example, they would like us to calculate the surface area of the composite shape shown below. All right, looking at this composite shape, we can see that this bottom part is a rectangular prism, and on top of it, we have a rectangular pyramid. And I want to know what the surface area is going to be. So once again, I need to know the area of all of its outside faces, and once I know those, I can add them all together. Okay, so why don't we start with the rectangular prism? Now, for a rectangular prism, I know there's a surface area formula. S equals 2 times length times width, plus 2 times length times height, plus 2 times width times height. All All right, now I would use this surface area formula for a rectangular prism where I can see all 6 faces. All right, however, when I stack a pyramid on top of the rectangular prism, I can no longer see the top face. So I have to change this formula slightly. All right, the top face, if I think about this, the top is the same as the bottom face. And to get the area of the bottom face, I would need to take the values of the length and the width and multiply them together. Once I knew the area of the length and the width on the bottom, I would multiply that by 2 to get the area of the top. Since I'm not going to be able to see the top face, I'm not going to multiply length times width by 2. So for my formula right here, instead of saying 2 times length times width, I'm going to get rid of that 2, and I'm just going to do length times width, again, because I can't see the top face when I put the pyramid on top of the prism. So now let's go ahead and substitute in our values. The length is 9, the width is 9, and 5 is going to be the height. So I'm going to have 9 times 9 plus 2 times 9 times 5 is the height, plus 2 times 9 is the width as well, times 5 is the height. We go ahead and we do the multiplication here. We're going to have 9 times 9, which gives us 81, plus 9 times 5 is 45. If you double 45, that gives you 90. And you're going to have 90 again. And now all you have to do at the end is add everything together. Well, 90 and 90 makes 180. And add 81 to that. The surface area is going to be 261 square feet. And again, that's only for the 5 faces of the rectangular prism that you could see. The front, the back, the left, the right, and the bottom face. Again, you can't see the top when you put the pyramid on top. Now we need to deal with the pyramid that we have on top. And again, the way I would find the surface area of this pyramid is by finding the surface area of all 5 faces, the 4 rectangles, and the square base. But again, when I take that pyramid and stack it on top of the rectangular prism, I'm no longer going to be able to see the square base. So really, the only thing that I have to do now is find the area of the 4 triangles. All of the triangles are congruent because we can see here, this distance is 9 feet, and this distance is 9 feet as well. So they share the same base, and their height is the same as well. That's 6 feet. So let's find the area of the triangles now. We're going to do area equals 1/2 base times height. The bases are 9 feet. 1/2 times 9 times the heights are 6 feet. Well, I know 9 times 6 is 54, and half of that is 27 square feet. And now I know that there's 4 triangles that are similar to each other. 4 times 27 is going to be 108 square feet. Now, in order to get the total surface area, again, I'm just going to add everything together. 261 plus 108, and that's going to give us 369 square feet as the total surface area for this composite shape. In the next part of our lesson, we're going to look at the volume of composite prisms. Remember that volume deals with the amount of space on the inside. Our first example says to find the volume of the following 3-dimensional object composed of 2 right rectangular prisms. Okay, we can see here we've got a smaller rectangular prism stacked on top of this larger rectangular prism. We need to find the volume. Okay, so just like we did with our surface area problems, we're going to break this up into 2 different solids. I'll find their volumes, and then once I know both of those, at the end I can just add them together. So why don't we start with this, I'll call it the top rectangular prism. Okay, for a rectangular prism, to find its volume, remember that you have to find the area of the base and then multiply it by the height. To get the area of the base, you multiply the length by the width. So really our volume formula is length times width times height. Looking at this top prism, okay, this length measurement right here is the same as this, so that's 4 meters, times the width right here is the same as this, which is going to be 5 meters, and the height here I can see is 5 meters. So I'm going to do 4 times 5 times 5. 5 times 5 is 25, times 4 is 100 meters cubed for volume. Remember to cube the units. Now I'm going to look at the bottom prism. It's also a rectangular prism, so my volume formula, once again, is going to be length times width times height. And for the width, or for the length and the width, I should say, I need to figure out what these measurements are. This entire measurement and this entire measurement right here. So let's start with the length. Okay, I know this measurement is the same as this measurement, which is the same as what we would have in the back here. Now I can see this segment here is 6 meters. So if I extend this from here to here is 6 meters. I need to figure out how much this measurement is. Well, this segment is the same as this segment, which we said before was the same as this segment. So this is 4 meters. So 4 meters and 6 meters makes a total of 10 meters for the length. For the width, it's going to be something similar. I need to know this measurement, which is the same as this measurement, and that's going to be the same as this entire measurement. Now I can see this is 5 meters, so if I extend this over from here to here, that's 5 meters. And I need to know this measurement here, which is going to be the same as this measurement, which matches what we have here. This is also 5 meters. So 5 meters and 5 meters makes a total of 10 meters for the width. The height of this bottom prism is simple. That's just 3 meters. And so we'll multiply 10 by 10 by 3. 10 times 10 is 100. Times 3 is 300 cubic meters. And now for the total volume, all we're going to do is add them together. 100 plus 300 makes 400 cubic meters for the volume. In example number 2, they ask us to find the volume of the following three-dimensional figure composed of two right rectangular prisms. Okay, so this time we have a rectangular prism that's in the front, and it's attached to a rectangular prism there in the back. And just like with the last example, I'm going to want to find each of their volumes, and then I can find the total volume by adding at the end. So why don't we start with this front prism? It's rectangular, so our volume formula is going to be length times width times height. And so I can see right here that it has a length of 6 inches. It has a width of 2 inches. And for the height of this prism in front is the same as the height of the prism in the back, which I can see right here is 9 inches. And so all I have to do is multiply 6 by 2 by 9. 6 times 2 is 12, and 12 times 9 gives us 108 cubic inches. Now I'm going to do something similar for the back prism. That as well is a rectangular prism, so the volume formula, volume equals length times width times height. And for the dimensions, it has a length here of 10 inches, a width of 2 inches, and the height we discussed earlier was 9 inches. 10 times 2 is 20. 20 times 9 is 180 cubic inches. And once again, to get the total volume this time, we will add 108 with 180, which gives us 288 inches cubed for the total volume. In our next example, we have a triangular prism, and it has a hole cut out of it that's also in the shape of a smaller triangular prism. They want us to figure out what the volume of the prism, the big triangular prism, would be once we cut out that hole. All right, so we're going to start by finding the volume of the big triangular prism. Okay, that would represent the total volume of the full shape, and then we'll deal with the hole in just a minute. For a triangular prism, the volume formula is just 1/2 of the length times the width times the height. So we're going to have 1/2. Now, the length of a triangular prism is the segment that connects the two triangles together. In this case, that's this segment right here, which I can see is 4.5 centimeters. I'm going to change that into decimal form, 4 5/10 for the length. For the width and the height, those need to come from the triangular face, and remember that they need to be perpendicular to each other. So I'm looking to see where the width and the height form a right angle. And I can see that this segment and this segment right here form a right angle. So I can use the values of 4 centimeters and 3 centimeters, because that's what this measures back here, 3 centimeters, as my width and my height. So 4.5 was the length, 4 centimeters can be the width, and the height here can be the 3 centimeters. If we go ahead and multiply here, we're going to have 4 times 3 is 12. Okay, so we're going to have half of 12 times 4.5. And I know half of 12 is 6. So I just have to do 6 times 4.5. And that's going to give me 27 cubic centimeters as the volume. Now I have to figure out the volume of the hole. And the hole is in the shape of a smaller triangular prism. So now let's do a small triangular prism. And not get in the way of the big triangular prism. Volume formula again is going to be 1/2 the length times the width times the height. And again, I'm going to have 1/2 times. Now the length, again, connects the front triangular prism with the back triangular prism. This hole starts on the front triangle and goes all the way back to the back triangle. So the length is still going to be 4.5 centimeters. For the width and the height, again, I'm looking for where that's perpendicular on the small triangle. And that's here where it's 2 centimeters by 1.5 centimeters. Those are perpendicular to each other. So I can use 2 centimeters for the width, 1.5 centimeters, 1 5/10 centimeters for the height. If I multiply here, 1/2 times 2 is just 1. So I'm just going to have 4.5 times 1.5 that I need to multiply together. And if I multiply 4.5 by 1.5, that gives me 6 75/100 cubic centimeters as the volume. Now, in order to get the total volume, this time, because there's been a hole that was cut out of the solid, I'm going to take the entire volume, 27, and subtract out what was cut out, in this case, 6 75/100 centimeters, cubic centimeters. And that's going to leave me with a total volume of 20 25/100 cubic centimeters as the total volume. Okay, when there's a hole cut out, you have to do a subtraction at the end to get the total volume. In example 5, we're once again dealing with a solid that has had a hole cut out of it. A square hole with side lengths of 4 inches is drilled through the cube. Determine the volume. Okay, so we see here that we're working with a cube. That means the length, the width, and the height are all the same measurements. They're all 12 inches. There's been a square hole cut out where each side of this square hole is 4 inches. So that's 4 inches, that's 4 inches, and it goes all the way through the cube. We're going to try to figure out what the volume of the cube is after the hole has been cut out. So let's imagine that it was a whole cube to start. In order to find the volume of a cube, volume equals length times width times height. And in this case, when we look at that, well, all of them are 12 inches. So it's going to be 12 times 12 times 12. Okay, so we just have to multiply 12 by 12 by 12. And that's going to give us 1,728 inches cubed. So that would be the volume of the cube if there wasn't a hole in it. Now we have to account for that square hole. Okay, well, if we think about this hole, that's going all the way through to the bottom here. Okay, so if we imagine that, okay, that's in the shape of a rectangular prism. And in order to find the volume of what has been cut out for a rectangular prism, I'm again going to do length times width times height. For the length and the width, they told me that it's 4 inches by 4 inches. This was a square hole, 4 by 4. And for the height, it goes all the way through the cube, so that has to be the same height as the cube, which was 12 inches. And so we're going to multiply 4 by 4 by 12 in order to find the volume of the hole that was cut out. And that gives us 192 cubic inches. Now to get the total volume, which is the cube with the hole taken out of it, once again, we're going to take the entire volume and subtract out the hole. And if we do 1,728 minus 192, that's going to leave us with a total volume of 1,536 cubic inches.